Hello students, welcome to your virtual classroom. This is Mansi Bhosle, your mentor for maths and physics. I will be dealing with a lot of topics pertaining to classes 9, 10th, 11th and 12th. Hope you have a great learning experience with me. So today we will be dealing with topic from class 10 maths. Let's do quadratic equations. So for today's class, I am going to introduce you to quadratic equations. Basically, what do you mean by a quadratic equation, and the general term and the roots, what do you mean by the roots of a quadratic equation. So let's start. So what do you mean by a quadratic equation? Basically, we have learned about polynomials in our previous classes. What are polynomials? Polynomials are basically combination of, you can say, variables. Then there are coefficients which are attached to these variables, and there are also constant terms. Okay. We had studied till now, we had studied three types of, you can say, polynomials. So they are linear polynomials, quadratic polynomials, and cubic polynomials. So when I say linear polynomial, so basically linear polynomial is of this form: ax plus b, wherein a is the coefficient of x, b is the constant term, and x is your variable. When I say quadratic, so it has to be ax square plus bx plus c. When it is cubic, it has to be ax cube plus bx square plus cx plus d. So as you can see, numbers which are attached with the variables. What are the variables over here? The variables, I can say the variable is x. What is a variable? Variable is an unknown quantity which we are going to find, right? So a, b over here, a is a coefficient, b is a constant term. In a quadratic polynomial, a is coefficient of x square, b is coefficient of x, c is a constant term. Over here, a coefficient of x cube, b coefficient of x square, c coefficient of x, and d is again a constant term, right? So these are polynomials. What makes it linear, what makes it quadratic, and what makes it cubic? The thing wherein we are able to differentiate these into different types of polynomials is basically the degree of the polynomial. Now, what do you mean by degree of the polynomial? Degree is basically the highest power. The highest power, okay, or you can say the highest exponent. Now, in case of a linear, do you tell me which is the highest power? The highest power, and power will always be of the variable. Okay, power, the exponent we have over here, we have to see the exponent of the variable. Okay, so over here power is 1, so degree 1, it becomes a linear. Can you tell me about quadratic? What is the degree? Degree is 2, so it becomes a quadratic. In cubic, degree is 3, so it becomes a cubic. When the degree is greater than 3, we give it a generalized term, that is a polynomial, right? So when degree greater than 3, generally we call it a polynomial. Okay. Now, when does this polynomial becomes a equation, or now as we are dealing with the topic of quadratic equations, when does this quadratic polynomial becomes a quadratic equation? When I say equation, obviously equal to sign has to be there, right? So when I just equate my quadratic polynomial with 0, it becomes an equation. Like for example, ax square plus bx plus c equal to 0. This is my quadratic equation, or I can say this is the general term of a quadratic equation. And general terms are very important because, like, I mean, when we do relationships with coefficients and roots, general term would be very necessary, right? So over here, if this is the general term of a quadratic equation, a is called as coefficient of x squared, b is coefficient of x, and c is a constant. Okay, now, so what are the conditions an equation should have for it to be a quadratic? Okay? So condition number one, like when I say quadratic, we know that it is ax squared plus bx plus c equal to 0, right? So the condition for a given equation to be quadratic, first is a should not be equal to 0. Because if a becomes 0, we know that this entire term ax squared will also be equal to 0. So now your quadratic equation becomes basically a linear equation, which is bx plus c equal to 0. That's it, right? So a should not be equal to 0. A, b, c, all of three should belong to real numbers, right? They should belong to real numbers. And thirdly, most importantly, is that the power. Okay, so you can say power or exponent, or certain textbooks even say index. Okay, so index of these numbers should be a positive integer. Okay, exponent should always be a positive integer. So these are the three basic conditions for a given polynomial to be basically a quadratic equation. So let's take, for example, I am taking this. So let's see example 2x to the power minus 2 plus 3x plus 1. So if I say over here the degree, basically what is degree? Degree is the highest power, and over here the power is minus 2, over here the power is 1. So degree is 1. This is not a quadratic equation, right? Because if I take this minus 2 over down, it will be, this will get converted to in bracket x square plus 3x plus 1. It will be converted like, so this is not a quadratic, right? Another thing, another example I would take, like for example, let's see, 3 root x plus 3x plus 5 equal to 0. Again, over here, if you observe, x degree is 1 upon 2. Anything, if I say square root is always degree 1 by 2. So this is also not a quadratic equation. This is not a quadratic equation. This is also not a quadratic equation. Thirdly, again, another important thing for a given polynomial to be a quadratic equation is that it should have only one type of variable. So for example, if I say like 3x plus 5y square plus 7 equal to 0. Okay, degree is over here 2. Okay, it is like a is not equal to 0. ABC belongs to real numbers, power exponent is a positive integer, all these things are satisfied. But the most important thing, that is, there are two variables, one is x and another is y. So for a quadratic equation, we should only have one variable. Okay, so these are the simple basic rules that you have to follow when you need to find out whether a given equation is a quadratic equation or not. Let's have some idea now regarding roots of a quadratic. What do you mean by roots of a quadratic? Okay. Roots of a quadratic equation means the values of the variable. Okay, the values of x, which when we put into the equation, it will satisfy your equation. Like for example, if I say if the value of a polynomial is 0, if, or basically if the value of a polynomial is 0 for some value of x, let it be for x equal to a, then x minus a is a factor of this polynomial. Factor of that polynomial. Right? So if we have a polynomial like ax squared plus bx plus c equal to 0, and I have been given that x equal to say alpha, x equal to alpha is a root of this equation. So that means when I put the value, or when I substitute the value of x as alpha in this particular equation, it will be equal to 0. It will be satisfy the equation. That means LHS will be equal to RHS. Then I can say, yes, x equal to alpha is a root or is a solution of the given polynomial. So this thing, basically, when we say that the value of the polynomial is 0 for x equal to a, then x minus a is a factor of that polynomial. This is also called as factor theorem. Okay, this is also called as factor theorem. So in just to summarize, if let there be a polynomial p of x. So if p of x is a polynomial and the value of x is equal to a, value of x is equal to a, then p of a will always be equal to 0. Therefore, x minus a will be a factor, right? It will be a factor of p of x. Hence, we can say that a is a root, a, number a is a root, solution, or 0 of the polynomial. It has different names, right? It can have, it is also sometimes in some textbooks or in some text it is called as roots. In some it is called as 0 of the, find the 0 of a polynomial, find the roots of a polynomial, or in simple terms it can be solution of a polynomial. Find zeros of the polynomial, then you can say roots of the polynomial, solution of the polynomial. Okay, that is what we mean by roots of a quadratic. Let's take some examples now. I have my p of x equal to x squared plus 5x minus 6. Okay, now let x be equal to, let the value of x be equal to minus 6. x is equal to minus 6. So therefore, what we will find out, p of minus 6. This will be equal to minus 6 whole square plus 5 into minus 6 minus 6. So we know what is minus 6 whole square. It is 36. 6 5s are 30 minus 30 minus 6, just the way it is. And then we know it will be 36 minus 36. It is equal to 0. Okay. So whether x equal to minus 6, whether this is a root of the given polynomial, yes, it is root of the given polynomial. Why? Because p of minus 6 is equal to 0. That means when we put this value x is equal to minus 6 in the given polynomial, it is satisfying the equation. So therefore x equal to minus 6 is a root of the given quadratic equation. Second one says p of x be equal to x square plus 5x minus 6. Again the same one, but now the value is different. Now over here, let x be equal to 2. Okay, so now what we'll do, we'll just put up this value of x in the given polynomial instead of substitute this as, so p of 2 is equal to 2 square 5 into 2 minus 6. What is 2 square? 2 square is 4 plus 10 minus 6. So basically that's 14 minus 6, which is equal to 8. Is equal to 8. So is p of 2 equal to 0? No, p of 2 is not equal to 0. It is equal to 8, which is not equal to 0. Hence, I can say that x equal to 2 is not a solution of the given polynomial. Solution, or is not a root of the given quadratic equation. Okay, let's do some more examples. 3. It says if x is equal to 5, okay, if x equal to 5 is a root, it is given that this is a root, okay, this is a root of the equation kx square minus 14x minus 5 equal to 0. We have to find the value of k. How will we do that? We know that it is a root, okay, and if it is a root, that means p of k is going to be 0. P of 5 basically is going to be 0. Okay, if p of 5 is 0, so now let's substitute 5 in all the values of x. So k into 5 square minus 14 into 5 minus 5 equal to 0. So it is 25k. What is 14 5s are? 14 into 5 is 70 minus 5 equal to 0. So it's 25k minus 75. I will take this minus 75 to the other side, transpose it. So 75. So basically k is equal to 75 upon 25, which is equal to 3. So hence the value of k has come down to 3. Okay. So these were a few examples how to find out, whether a given number is a root of a given quadratic or not. Coming up next, we will have our next episode where we will discuss regarding the different methods of solving a quadratic. There are 3 methods of solving a quadratic. We will discuss factorization method, we will discuss completing the squares method, and we will also discuss the quadratic formula method. So stay tuned. Thank you for this session. Hope you liked my video. Any doubts, any difficulties, please post on the comments. When we complete a particular set of topics, I will be sharing with you many more resources where you can practice the questions, and ample of practice questions will be given, be it state board, be it CBSE board, be it ICSE board. Thank you. Hope you enjoyed the session. Please do like, share, and subscribe my channel if you feel something was good. Okay, thank you.